Hey guys, so 9.5, which you all should have the sheet for. 9.5 is conditions for special parallelograms. It's pretty much what you already got last time with the worksheets and stuff, like the conditions, all those note sheets I gave you. So we're going to go over it again. Like this videos are just really going to be a sequence of me helping you with the stuff because we've already done it. Okay, so I don't, like the other classes split it into two, like teach you about what rectangles, rhombuses, and squares are, and then add it on. This is the same stuff. So this is going to be a pretty quick one, which is good because we're doing star testing and all that stuff. So anyway, locking it down. So I'm going to work on side B because, as you know, side B is usually the more difficult one. So we're going to work on side B. Hopefully that corresponds to side A a little bit. And I'm not going to do side A, but I'm going to help you with side A if that makes sense. So I mean, you'll get what I'm saying. So I'm gonna start off on side B. So on number one, it says, and you can read the problem, but essentially it tells me I have two 2,300 foot long sides and 250s. It says, tell additional information you need to know in order to determine whether the reflecting pool is a rectangle. First, we have to show its parallelogram. Okay, so first, to be a parallelogram, I need to know opposite sides are congruent. I need to know that, right? Because if I don't know that, it's not even a parallelogram. Because it can't go 150, 150, 2,300, 2,300. That's not a parallelogram. It has to be a parallelogram first, so I need it in this sort of shape. 2,300, 2,300. 150, 150. I need it like this. If it's not something like this, then it's not a parallelogram. Once I have that, what additional information do I need? We talked about this last time, that for me, my rectangle test is to prove that the diagonals are congruent. So, I need to know what? The diagonals are congruent. Or the sides are perpendicular. Because if these sides are perpendicular, that means 90 degrees here. And if this is 90, it's parallelogram, so this has to be 90. But if this is 90, it's parallelogram, this has to be 90. And if this is 90, this has to be 90. Hey, it's a rectangle. So I need to know either a pair of sides it's a parallelogram and there's a 90-degree angle in it, which causes the rest to be 90 degrees. Or I know the diagonals are congruent. And that's how I do number one on side B. Okay? Pause if you need to. Still on side B. Two, determine whether the conclusion is valid. If not, tell additional information you need to know. Got a picture like EA. So you're told that AC and BD bisect each other. That means this and this is true. Is it a square? The diagonals bisect each other means one thing. One thing. It means they share the same midpoint. If they share the same midpoint, it means it's a parallelogram. So this right here is just a parallelogram. That's all I have right now. Okay? So if you want to step it up, so I know the diagonals are bisect. That's a parallelogram, okay? If I want to know it's a rectangle, I need to show diagonals are congruent. It gives me the rectangle. And if I show the diagonals are perpendicular, that gives me that it's a rhombus. And if I know if it's all true, then it's a square. Notice a square is just a combination of a rectangle and a rhombus. So there you go. Okay? Cool. So let's look at number 2, the second one, or all right, 3. AC is perpendicular to BD. Okay, AC is perpendicular to BD, means which we have right angles here. Awesome. And AB is congruent to BC. So AB is congruent to BC. Check it out. 90-degree angles. These things are the same. Do I have enough? Do I have enough to determine that this is a rhombus? Sadly, no. I want to. I really, really want to. Here's the problem. This here tells me nothing about these sides. It tells me nothing about the lengths. I need to know it's a parallelogram first in order to say it's a rhombus. I don't have that, okay? This would make it a rhombus if I knew it was a parallelogram. I don't know it's a parallelogram. If I had a way of showing these two were congruent and these two were congruent, that'd be great. But right now, I don't know for sure that it's a parallelogram. And it can't be a rhombus if I don't know it's a parallelogram, okay? I can't say for certain that it's a rhombus unless I can say for certain that it's a parallelogram. So it's not. It's not for sure a rhombus. What I need to know is that it's a parallelogram. How do you determine that? Both pairs of opposite sides are congruent, both pairs of opposite angles are congruent. I need something to prove it's a parallelogram first, okay? So go with your definition of parallelograms on that one. All right, number 4, four horsemen. AB is congruent to DC, so these are congruent. AD is congruent to BC, so these are congruent. Measure angle ADB. ADB is 45 degrees, and it's the same as measure angle ADB. Okay, cool. And the conclusion is it's a rectangle. Well, this is 45 degrees here, right? So that means this whole thing is 90 degrees. And this is 45 degrees. Hold on. First of all, it's parallelogram, right? Awesome sauce. Great, right? Good. I know this is the same as this. Do I have enough to show it's a rectangle? If somehow I could say that these two are the same, then it's true. Problem is I don't have that. Again, I don't have that. Or is it a square? I don't have enough. I really, really wish I did. I know AB and DC are the same. I know BC and AD are the same. But I don't know that these two are equivalent to each other. So unless I know these two are equivalent, I can't make it a square. If these two were equivalent, if I also had a BC is equal to DC, so if I had BC is congruent to DC and the diagonals BD bisects angle ABC and angle ADC, then I would have enough information. Because if it bisected, that means these are both 45s, which would make this a 90, make this a 90, and then these would all be the same, and it would be a square. But I don't have that information yet. I've not been told that, so I can't just assume it. All right? Last little bit, last one, number 5. You're told we're told that AB is parallel to DC, AB is parallel to DC, and AB or AD is congruent to BC, and AC is congruent to BD. So these are congruent here. All right. Is it a rectangle? first of all, is it a parallelogram? Again, this sucks because it's just tiptoe. I don't know that these two like bisect each other. If I don't know they bisect each other, I don't know it's a parallelogram, so I can't use that. I need both pairs of opposite sides are parallel. We'll have one, I don't have the other. I need both sets of opposite sides are congruent. I have one, not the other. I don't have enough information to say it's a parallelogram, so I can't do anything. Like, if I can't even lock down it's a parallelogram, I cannot prove anything else, okay? What I'm saying is, you have to show it's a parallelogram first, okay? So, inside parallelograms, there are rectangles and there are rhombuses. And inside the two of them, there are squares. Okay, squares are here, rhombuses, rectangles, parallelograms, and then quadrilaterals. If I can't even get into parallelograms, how am I going to invade rectangles? How am I going to invade rhombuses? And if I can't even get the parallelograms, so I can't get into rectangles, how am I going to invade squares? Think of it this way. You have to invade the United States in order to invade Missouri, and you have to invade Missouri to invade Colombia, okay? If you can't even invade the United States, you're not touching Colombia, because just because you invade the U.S. doesn't mean you can touch Missouri, and just because you can touch Missouri doesn't mean you can touch Colombia. You know what I mean? So that's why we have to show the parallelogram first. We can't. It's done. So we have to prove it's a parallelogram first. So if we knew these sides were congruent, that make a parallelogram. Well, now I know these diagonals are congruent, so it's a rectangle automatically now. And that would be enough. But I have to do something. Either show these sides are congruent or show that these sides are parallel. Something. Okay? I need that relation. Or that these bisect each other. I need something to prove it's parallelogram. We'll move on to 6. This video is a little long, but you know, what else? It's the same as me doing a worksheet in front of me. Number 6 simply says, find the lengths of the diagonals to determine whether the parallelograms of the given vertices is a rectangle, rhombus, or a square. So for 6, for EG, I'm going to use distance. So that's going to be, and I'm going to do the left side of 6 and 7. And, well, actually, I only need to do 1, really. I'm gonna do 6. You guys will do 7 on your own. So I have -2, -4, and -3 to 1 are my points for EG. This is E, and this is G. So first off, we need to do distance. So how far is it from -2 to -3? How many units apart are they? You have to do it, count it on number line. -3, -2, 1 unit. Woo! How far is it from -4 to 1? So again, we can count it on our number line. 1, 2, 3, 4, 5 units. So I'm looking at the square root of 1 plus 25, so the square root of 26 units. So that's my distance. So the answer to 6 EG is equal to square root of 26, okay? For the slope, I'm going to do the same sort of thing. For my slope of EG, remember the formula? Y2 minus Y1 all over X2 minus X1. Boom. So I'm going to do -4 minus 1 over -2 minus -3. So I get -5 over 1, so it's -5. Cool. So we've got EG and its slope. Yay! Then we over here, I've got FH. Same thing. How far is it from 0 to -5? That's going to be 5 units. How far is it from -1, -2? That's 1 unit. Hey look, 5 and 1 again. 5 and 1 again. So it's the square root of 25 plus 1. square root of 26. So the distance of FH is equal to square root of 26. Those match. We'll use that in a minute. And then the slopes. Just because the distances match doesn't mean the slopes will. Okay? So don't think just because these numbers all match that we're done. We're not. You have to do the math. Alright. Sorry, I just get worked up. People are like, oh, this looks the same. I can just do it. No, you can't. You don't make assumptions. You do your work. You prove that you're right. And don't just go, well, I think I am. I think I can doesn't cut it versus I know I can, all right? I'd rather have a million, I'd rather have one I know rather than a million I thinks, okay? And that's truth. All right, slow. I'm going to do -1 minus a -2 all over 0 minus -5. So I've got 1 over 5. So that's my slopes. All right. Okay, if I compare these two, what type of shape is this? EG is a diagonal. FH is a diagonal. The diagonals are congruent parallelogram. Boom. The slopes of the diagonals are perpendicular. They're the opposite reciprocals because -5/1 is the flip of 1/5 and you change the signs. So signs change and you flip the fraction. That means, what that means is straight up honest, these are perpendicular. Diagonals are perpendicular is a condition of a rhombus. So it's a parallelogram, and since it's a parallelogram, it can also be a rhombus, and it is a rhombus. So yay, we can prove it's a rhombus, and we're done. Let's see, front side, 1 through 6 definitions, boom. You should be able to do that with all the note sheets you have. 7, you should be able to do that by definitions. 8 by definitions. 9, 10, 11, 12, all definitions. You should be able to do side A based on definitions. I hope the STAR test went well. I hope the worksheet goes well. Rockhold out. Okay, I'm back in to shut it off.